Today I'm going to show you how to walk through an inquiry-based science investigation with your child. The most important thing is to simply wonder about the world, and then from that wondering, you create investigations and find answers to your questions. Here is an example.
Last time we were up here, I couldn't use the water in the house, so I got the idea of using the electric stove to melt snow. And the snow would turn into water, and I could heat up the water to wash dishes and for minimal purposes. So I thought, how much water does snow create if you fill up a whole pot and it melts down? And I did that, but I didn't really measure it. I just kept adding snow because as soon as it melted, it wasn't very much water. So we needed to do an experiment to actually measure the amount of snow that melted down to a different, smaller amount of water.
Developing a good question will guide your entire experiment. This format is what is the effect of something on something else, and all you have to do is determine what you want to study and fill in the blanks. For example, what is the effect of eye color on pupil dilation? You'd be measuring pupil dilation. Or how does the humidity affect the growth of fungi? You would be studying the growth of fungi. Finally, which foods do mealworms prefer? You would be offering mealworms different foods and measuring.
How much does the density of snow affect the volume of water that it creates when it's melted?
Next, you have to do some research, and this is something that will vary depending on how old your child is. But together or independently, you could read about your topic and also discuss what you know or what experts know or teachers or anyone who could help you out. Our hypothesis is an informed guess about what we think will happen. I think it will create 3 times more if we pack it, but actually, my mom thinks it will create 5 times more. So we're only going to have 2 different, two options for the independent variable. Packed as much as we can or totally loose. Determining a rationale is important to really show how this experiment is authentic and important in the real world. Sometimes snow falls and it's very light and powdery like we had today. Other times, due to atmospheric pressures and temperatures, it's very heavy and dense, which we tried to recreate by packing.
The reason an experiment like this is important is to measure the total amount of precipitation year-round, both in snow and in hail and in rain in the summer, and so that it forms into lakes, groundwater, streams, water supplies, feeding, watering crops.
Collect your materials and create a written procedure. Notice that when I am asking my mom what units to use to measure, she first says cups, and I don't tell her that that's not as precise. I kind of guide her with some questions. You can do this as well. You can also do that with determining tools. We decided we would fill a pot. These are our materials right here. Fill 1 pot with snow. We have a spatula to smooth it out so that we have exactly 1 full pot. We are going to cover it, this is my idea, so that none of the snow evaporates while it's heating up. And we're not going to bring it to a boil or anything. We just need to melt it. Really, you could do this inside and just let the snow melt, but it was more fun to have a fire. We also considered just doing this over the stove for you city dwellers, but it was more fun to have a fire. So we're going to be melting snow over the fire. First, 1 loose pot, then 1 packed pot. First when we melt the loose pot, we need to measure it in our measuring cup. What unit are we going to be using, Mom?
Well, that's 2 cups.
But what unit will we be using to measure?
Cups.
Ounces, cups?
Cups.
Okay, cups.
Well, we're using cups of snow, but it may not be a full cup of water,
We're not
we don't
using
think.
cups of snow.
Okay,
We're using 1 full
ounces.
pot. Okay, why would you choose ounces?
Because the measuring instrument breaks it down to ounces, And I think that we are going to be measuring ounces of water,
Why?
not
No, why
cups.
not cups?
Because I don't think that pot will produce a cup of water. So I want to be more accurate.
More precise. Yeah? All right, I'm going to fill up 1 loose pot of snow, so that means I can't pack it at all. But that's not a pot, that's too much. One perfect pot of snow.
Those are flame-proof gloves.
They are.
Well, they're not flame-proof, they're flame-resistant.
Totally!
It looks like almost a cup to me, but no, maybe I'm not. Oh, wow! 10.5
We have to have it.
ounces. Now we're going to do the experiment, filling the pot up with snow that's been packed down. Yes, I've just determined it's all melted.
Not quite.
Okay, that's 16. We don't need that anymore. And now the rest of the water. Wow. 24.
So the first one was 10.5, more than double.
Wow.
But not triple like I thought, and you thought 5 times.
Oh, yeah, that's right.
But that's fine, it's fine. It's just
a guess, just a
guess.
hypothesis.
Your data should be recorded on a chart just like this. Our independent variable was the density, so variable 1 was loose snow, variable 2 was packed snow. We would record how much water was created, and we would have done that whole thing 3 times. Next, you're going to organize your data in either charts, graphs, or pictures, some way you can look at it and analyze it. And the final thing you have to do is restate your hypothesis now that you have that new information with the conclusion. The final step is to talk about its application in the real world. How could this really help people to know this information? Talk to experts, see if they do have this information or could use this information. And the best thing you could do to really make this an authentic experience would be to determine something you could do in your house, in your kitchen, or even in the community to improve it. For example, if every time you cook popcorn, the pan burns, you could test that by asking yourself, how does the intensity of heat affect the amount of burn that occurs while cooking popcorn? You would do that by changing the intensity of heat and recording how much burn there is on the bottom of your pan. You would obviously do this multiple times in the way we have conducted our investigation today. If that didn't work, or even if it did work, you could try again and ask, how does the amount of shaking affect the amount a pan burns while cooking popcorn? This is a way to improve your house, your kitchen, and your life, as well as possibly the world. Kids are powerful. The more authentic this is, the more actually applicable it is in the real world, the more excited your child will become. And truly, they are the ones who are going to be creating progress in the future. So, create your scientist today. Wonder about the world. As we were creating this investigation, this is how cold it was.
It is 2 degrees, but it is very windy, and the wind chill is maybe 15 or 20 below, I don't know. Last night it was 19 below zero.